Hi. So last week, Elliot demonstrated a new feature we have called Origin Secrets, which lets you upload encrypted strings to expose to your builder builds. This is useful for things like credentials, SSH keys, and the like. You might want to capture certain strings, like your AWS keys, for example, and use them in your builder builds. And so today I'm going to show you how that looks in the UI. So I have an origin here, my personal origin. And I also have a plan file that I've connected to Builder over here on GitHub. It's just a test app, it doesn't really do anything. I'm going to create a secret and then upload that secret to Builder and then run a build that shows it in the UI. So first thing I'll do is I'll use have origin secret to upload a secret. I'm going to give it the name, the key of some key and the value of some val. Upload that. Okay, so that's been encrypted locally and uploaded to Builder. So if I reload here, I will see that in the UI. It doesn't show the value because we don't want to do that. We just want to let you know what keys are there. I could delete that if I wanted to, but I won't. And I'm going to make a change in my plan file here, and I'm just going to output a build line. And I'm going to say some key just to show what that value is. We'll commit that. And if I pivot back over to Builder, I'll go to that package for test app. I should see a build running. If I go down here, I should see that value emitted in my build here. Let's see if that happens. There it is. So yeah, some key, some val. And I think that's pretty much the demo. Like I said, if I want to go back and modify those keys, I can. I can go and tidy up here. Oh, I want to go here actually. And remove the key, and yeah, that's it.
Hey, this is Josh Black, and I'm going to demo logging into Habitat Depot via Bitbucket. So today, if you come to the production site, you're greeted with this, sign in with GitHub. But now you can sign in with Bitbucket. So this is an on-prem Habitat Depot that I'm hosting on EC2 for the purposes of this demo. And if I click sign in with Bitbucket, it redirects me to Bitbucket as you would expect, and I grant access. And I get redirected back here, and now I'm logged in. I can go to my profile, and it tells me about my Bitbucket account that I'm logged in with and all that good stuff. And this is all controlled via a configuration file here where you set up your provider and a few different OAuth endpoints, and everything just works. So yeah, that's signing into Habitat Builder via Bitbucket. Hello, this is Josh Black, and I'm going to demo bootstrapping a Habitat on-prem depot in an air-gapped environment with a set of packages. So to do this, we have a script called on-prem archive. You can run it and create an archive, and when you do this, it's going to pull down the core plans repository, go through every plan in there, download the latest stable version of that particular archive and all of its transitive dependencies, and put them all together into a giant tarball and upload that tarball to S3. So for this part of the process, you do need to have network access in order to upload it. But the next step where you actually populate the depot, you don't. And since this takes kind of a long time, I'm gonna skip ahead to where it's actually finished. So as you can see here, it finally finished. And in addition to all the stable packages. It also packaged up all the public keys that currently exist, put them into the tarball, and uploaded it to S3. So now that this archive has been created, we can use it to bootstrap a depot. So to do that, we do this again, and in an air-gapped environment, you probably want to download the file before actually bootstrapping. So you can say download archive. And that downloads this file, which is, again, going to take a little while, so I'll skip ahead until it finishes. So now we finished downloading our archive, and we want to use it to bootstrap our depot. So let's do that now. And I forgot to export my token. One moment. So now I have my OAuth token in my environment, and let's try this again. So if I hadn't specified a local archive here, it would have downloaded the latest one off of S3 and used that one. But since I specified a local file to use, that's the one it's going to use. And again, this process takes forever as it expands the entire archive into all the hearts and then manually uploads each one of the hearts to the depot. So I'll go ahead and once again skip ahead until it's done. And now we come back at the end of this upload process and see that all of the artifacts have uploaded to the depot. So that's the process of bootstrapping an on-prem Habitat depot. Thanks for watching.
Hi, everybody. I'm going to demo configuration and installation of the Habitat on-premise builder services. For context, ever since we released Habitat V1, one of the top asks for us has been to allow the Habitat builder and depot to be deployed on-premise behind a firewall so that enterprises and whoever wants to can host their own packages off on the site and not on the cloud SaaS service. And so finally we've enabled that, and we've just released the very first version. It's currently MVP alpha version for our early development partners. But we have this out here now, and I'm going to quick show you how easy this is to get it all set up and just kind of run through the setup and configuration for the on-prem builder. So what you're seeing here is on the right-hand side is our GitHub repository. It's got pretty much all the instructions and all the scripts that are needed to set up the builder environment on-premise. And if you just go through a little bit of it, you can see some of the requirements. There's not a lot. You need to have a place to run these services. You need to have some outbound connectivity, at least for the install. And then you need to have OAuth provider. We currently support GitHub, GitHub Enterprise, and Bitbucket. And then we will be adding more providers as we go along. And pretty much all of the functionality that you have with regular builders there, you can log in and create your origins, keys, and host your packages. What we're not providing yet is the build functionality. That is something that will also come a little bit later. So let's just kind of run through. Let's go through the prerequisite. All you need is a OAuth app setup. I already have mine set up here. If I go to my developer applications, I have this Habitat on-prem OAuth install. Main thing I'll need is the client ID and secret. I'm going to be revoking the secret after the demo, but we have these two things. And then the rest of the config is pretty simple. You just need the URL and a callback here. So that's the app. And we'll go back to the README. Basically, you just need to set up your environment here, builder.environment with these settings. So I'm going to show you mine. It's pretty simple. Here it is. It's already pre-configured with the endpoint URLs for OAuth. It's got the client ID and secret and the callbacks. And that's the main thing. So then I'm just going to run through a simple install script. And what this is going to do is going to set up a hab binary if you don't already have it. And it's going to set up the Habitat services. We have about 5 services to set up here. It's going to download and set them up. And once those services are set up, it's basically going to get them started running. It's going to create any of the specific configuration that it needs for the services. And that's pretty much it. It's all pretty seamless as far as the setup goes. So this is going to take about a minute or so. And then while it's running, maybe I'll go through a little bit more of what's in this README. Once this is set up, we kind of walk people through how to set up the web. They don't have to set anything up. They can just go to the web UI and start using it. And then, they'll probably want to create an origin and have a person access token generated to do the rest of the things. And then there's information here for bootstrapping and upgrading, troubleshooting, all those kinds of things are in here. But we're going to wait for this setup to complete. It's just going to be another minute or so, I think. And then we'll be able to go and start using the UI. Okay, so this is done. Before I go to the UI, I'm going to just do a have service status real quick, and I can see all my services are up and running. So now let's go to the UI. So it's hosted on localhost. I'm going to go right to the sign in, and let's try this again. Let's maybe check these services. Oh, okay, what's happening is I'm not on the right port, so I'm just going to go back here. And it should be coming up in just 1 second. And here it is. Okay, so I'm going to sign in. And it should just work. And here it is. So now I'm signed in. I don't yet have an origin. This is just kind of a clean builder environment. And the next step would be, as I talked about, creating an origin and person access token and doing the bootstrapping. We'll save the bootstrapping for a separate demo, but that's all I have for this one. Again, this is our very first version of on-premise Habitat Builder, and it's available now for our early development partners and others who want to use it. So thanks for watching the demo. I hope you enjoyed it. That's all I have.
Hi. So what we're going to demonstrate here is Habitat packaging and running SQL Server and load balancing, really, 2 SQL servers using its always-on availability group functionality. And then we'll have a .NET application running under IIS, also packaged and managed under Habitat that's binding to those databases. So right now we're on a VM hosted in Azure. So in this environment, we have a domain controller, a primary domain controller that's hosting a domain for us. In order for the high availability functionality to work right, we need a domain. We have 2 other VMs that are each running SQL Server. On this VM, I have a SQL Server Management Studio. This is just an admin GUI, really, that I can use to point to those 2 instances of SQL Server. I can see them right now. See them. They, so I can basically get information about their status. Right now, I know they're running in standalone mode. So if I were to try and look at their always-on information, I would basically get a little message that. Wait a second. Oh yeah, so get a little message basically says that this is not enabled. Here I have my app. So this app was literally copied and pasted from the Microsoft Entity Framework sample site. I didn't make any changes to the application. I just added a habitat plan, really. I chose an entity framework application because entity framework is Microsoft's ORM product. So for database mapping, it makes it easy to have a product that actually creates the database for me. The very first time I run this, it creates this database. Note that while this database is on SQL 3, there is no database on SQL 4. Another thing that our Habitat SQL Server package did for us, it has a post-run hook where we can add to a user toml, we can add a collection of logins. So a popular pattern in an enterprise scenario running a .NET web application would be to have those .NET web applications talk to SQL Server using a machine account. So a domain machine account, the account of the machine that IIS is running on, which would be this machine. So this machine is called admin. And so what our SQL Server package did for us, it added an admin login for us. So that's how we were able to authenticate into SQL Server and create that database. We can take a look at our web config for our .NET application and just prove to ourselves that we really are just pointing to an individual database right now. So here we are. So this is our connection string, and we're just pointing to a single IP. I just happen to know that this is SQL 3. So let's get the high availability functionality working. So to do that, I'm going to go. So right now on my top and middle consoles, I have SQL 3 on the top, and in the middle I have SQL 4. So on both of these, I'm going to start our SQL Server HAAG package, which, as you can see, is bound to SQL Server. So what these are going to do, let me get this one going too. What these are going to do is they're going to iterate. They're going to find all the supervisors that are running that service group, the SQL Server service group, and it's going to cluster them. There's a lot actually involved in that process. So first, it has to actually enable a Windows feature of the failover clustering feature in Windows. So it enables that. And then it configures it. So it creates a cluster. We have a user toml that we tell it what we want the cluster to be named. This could be called AG for availability group. It's going to add the nodes to that cluster. So each of these nodes will add themselves to the cluster. There's a little bit of a dance that it has to do there. They each add themselves. They wait for each other to be added. Then they're going to enable SQL Server, the SQL Server always on functionality in SQL Server, which interacts with that clustering. And then they enable all the little pieces that are involved in that. So there's replicas, there's mirroring endpoints, there's a listener which our Azure load balancer is bound to, and that's going to help us. That helps the load balancer direct the traffic to the primary SQL Server node. And so it sets all that stuff up. It also takes a backup of our database and restores it. So before it starts the replication, you have to have a restored version of that backup of that database on the secondary node. So it takes care of that for us too. So when this is done, we're all set to go. Let's see where we're at here. So this one, 3 is done, configuration complete, and 4 is done as well. One thing that we'll see when we see this happening is the actual SQL Server has to stop. So when you enable that feature in SQL Server, you have to restart SQL Server, enable for it to kick in. So what happens is our high availability package stops SQL Server, and then the SQL Server the supervisor running SQL Server says, "Wait a second, it just stopped," and then Habitat restarts itself, and then everything kind of hums along. So let's just take a look at the lay of the land now that that's all completed. I'm going to refresh my databases up here where before I saw none. I should now see. So now I see another database here. It's marked as synchronized. I'm going to refresh this one. It should also be marked as synchronized. So these are both synchronized across each other. Let's see, SQL 3, which I'm assuming is going to be the primary node. Yeah, so this is primary. So this should be secondary. Okay, and let's make sure my listener is here. Yep, so I got my listener. All right, so everything's good. My data is replicating. So now the next thing that we have to do is we have to bind our application. And so now rather than binding our application to our SQL Server service group, we want to add another binding. Let's see. We want to add a cluster binding. So we have an optional bind inside of this Habitat package for our .NET application that says basically, if I'm bound to a cluster, which we're about to bind it to, then use that cluster DNS name to point to instead of the first SQL Server supervisor in the SQL Server group. So, oh, actually, I have to stop this first. So, stop it. Now I'm just going to restart it. Okay. So restart the service. And so now we can cat out the web config again, and it should look differently. So I'll scroll up. Yep, so now the data source, rather than that individual IP address, I see it pointing to ag.wrock.test. It just so happens, let's see, ping ag.wrock.test. So that's ICMP isn't enabled, so these are not going to go anywhere, but I can see it resolves to 10.0.1.11. If I were to actually look at my Azure load balancer, we can see that it's bound to 10.0.1.11. So we should be set to go. Okay, so now let's just make sure that everything actually works. I'm just going to refresh this. And because I restarted it, this might take just a little bit because it's okay, that wasn't too bad. Let's just, for fun, let's put some data in here. Oops. All right. There we go. Okay, so we have data. So we're clearly talking to a database. So we're hitting SQL 3. So it's the primary node, and all of our requests are right now going to SQL 3. There's different ways that you can configure high availability. I didn't get too fancy with this, but you could also configure it so that all read operations get fanned out across all nodes, and write operations go to just one. Right now, everything is just going to SQL 3. So what happens if we actually kill SQL 3, basically? So let's do that. So SQL 3, we're going to stop. We're going to tell Habitat to stop SQL Server on SQL 3. And now if I go up to SQL 4 and I refresh my availability group, I'm going to expect it. Yep, so it's switched to primary. So now SQL 4 is my primary group, and SQL 3 is basically dead. So will things still work? Will the promise of high availability realize itself? Let's see. Yes, the answer is yes. I can still see my data. I can still talk to the data. It's the same data. And I'm talking to the other one. I could bring that guy back online now if I wanted to. I do. And this guy probably will remain the primary. But this one probably switched to secondary. There he is. Yeah, he's secondary. So that's really all there is to it. And we have SQL Server, high availability, Habitat, totally managed. That's it. Thank you very much.